Alright, here are the 5 properties of water. The first one will be high specific heat. Water has a very high specific heat energy because it is made up of hydrogen bonds. Water can easily absorb energy when it's hot and release it when it's cold because to actually change water state you need to have at least 100 degrees in temperature, which is quite a lot actually. And if we think about alcohol doesn't have any hydrogen bonds, so it's much easier to break up alcohol because all it has is London forces. Alright, next water property is it is a good solvent. Alright, so water is a really polar molecule because it's mostly made up of hydrogen bonds. So because it is really polar, it can break down solids very easily. For example, let's say here is a dipeptide. Dipeptide are just 2 amino acids. Here's also another one. So water is really good at breaking stuff down in our bodies as well. So let's say this amino acid is in our body and we need to break it down. Not only the stomach acid breaks it down, but water actually breaks it down as well. And this is a process called hydrolysis. So when a water goes in here, it breaks the 2 amino acids apart. Just like that. Next thing water is actually really good with is cohesion. Cohesion is the force of attraction between 2 molecules. So this is just repeating the idea of the hydrogen bonds, which is why water is just unique. It's because it's one of the most polar molecules. Because it is really polar and holds each other really tightly, the water is almost like a skin. So if this is the water, let's say there was one of those water spiders. Let me try to draw one. Alright, here's my attempt to draw a water spider. The reason why they can actually just walk on water is because water is really strong. It holds together really tight, and because of this, these water spiders are able to walk on water. If you would have put one of these spiders on, let's say, alcohol, it would just drown because alcohol doesn't have any polar or hydrogen bonds involved. All they have is London forces, and chances, or most likely, that spider will just sink and it will drown. And I kind of find that humorous. The fourth water property is capillary action. Capillary action. I can write it better. Capillary action. Alright, so capillary reaction. What the fuck is capillary reaction? Well, capillary reaction is when... how can I explain this? Okay, let's say there was a tree here. Here's my attempt to draw a tree. And we pour water under the tree. What we all know is that the water is going to get absorbed by the tree, and the tree is going to use that water to nourish itself. But how does this work? Why does the water go inside the tree? Why is the tree absorb the water? Well, this is from capillary action, and so the roots are almost like small thin tubes. And if you put this little tube in a glass of water, the water will go inside the tube and go all the way up. Have you ever noticed when they put water in a test tube, the water is never flat. There's always water on the sides going up. Now, why does this happen? Well, it's because the glass is actually polar. And because water and glass is polar, they attract each other. So water goes up the test tube. Now, if this test tube was very, very thin, and it was in a glass of water, it would go much higher than originally was. Now, if you made a test tube that was infinitely small, the water would go all the way up and may even just pour out. This is all because of hydrogen bonds. And last but not least, water is also ice floats. Water, yeah, there's no other title for it, just ice float. Water is promotes ice floats. Water properties, ice floats. It's midnight. I'm tired. I am sorry. I'm sorry. I'm just really fed up. Okay. Ice floats. Have you ever noticed when you put ice in water, the ice floats rather than drowning? Well, the reason this is the case is because ice is actually less dense than water. The density of water is about 1.0 grams per milliliter, and the density of ice is about 0.9 grams per milliliter. Now, why is ice less dense than water? Well, because the hydrogen bonds in the liquid phase, they rotate around. They not just vibrate, they rotate. So if this is the case, water could even move closer within itself, or the two molecules of water can move closer within, and another molecule of water can like squeeze in with it, and another molecule on the side can squeeze in as well. Whereas ice, they freeze in a certain hexagonal shape, or yeah, a hexagonal shape, or any kind of shape, more or less, but it has to form a shape that is equally distant from each other to prevent the different charges from staying too close. So here we have a slightly positive, slightly positive. When it freezes, these two are going to stay as far away from each other as possible. And because of this, water becomes less dense and it has this weird kind of like snowflake shape. It's an organized structure, which is why it's less dense than water, because if it's water, they all get cluttered up. And these are the 5 properties of water. They're quite simple actually. And yeah.